So watch part 1. Up to this we completed. Next we'll continue the session. Name a device that helps to maintain the potential difference across the conductor. By using what device you are going to maintain the potential difference? Battery. Clear? So by using what device you are going to maintain the potential difference? By using the battery. Next, what is meant by saying that the potential difference between the 2 points is 1 volt? That means they are asking us to define the unit of electric potential. What is the unit of electric potential? Volt. This volt we are going to define. How we are going to define 1 volt? 1 volt is defined as 1 joule of work is done in order to move a charge of 1 coulomb. 1 volt is defined as 1 joule of work is done in order to move a charge of 1 coulomb. Suppose if they are asking us to define 2 volt, means how we can define? 2 volt is defined as 2 joule of work is done in order to move a charge of 1 coulomb. So if you are having any confusion in this part, so by the time what you can do, just write the basic formula. What is the formula to calculate electric potential? V is equal to W by Q. Write the respective unit of all the quantities. What is the unit of electric potential? Volt. What is the unit of work? Joule. And what is the unit of charge? Coulomb. Suppose if they are asking for 1 volt, then how I can write? 1 volt is defined as 1 joule of work is done in order to move a charge. How much charge you are going to move over here? In order to move a charge of 1 coulomb. Next, how much energy is given to each coulomb? What is the meaning of the word each? 1. Energy means in our lower class we learned it's nothing but called as the energy. We can also call it as work. Now, how much energy? So you can just write it as W is equal to, that's what you are going to find, each coulomb. Coulomb is a unit of charge, then you can write it as Q is equal to 1 coulomb, and then passing through a 6 volt battery. Battery helps to maintain the potential difference, therefore V is equal to 6 volt. And what is the formula? V is equal to W by Q. If you need W, then you can use the formula W is equal to V into Q. So W is equal to, what is the value of V? 6. What is the value of Q? 1. 6 into 1 is going to be 6. And W stands for work, means, and what is the unit of work over here? The unit of work is joule. Next, how is the voltmeter connected in a series to measure the potential difference between the 2 points? That means how we need to connect the voltmeter? We need to connect the voltmeter only in a form of a parallel. So how we can draw a diagrammatic representation? Positive terminal, negative terminal. So across the ends of the conductor in a form of parallel, we need to connect the voltmeter. So the positive terminal is connected to the positive terminal of battery, and negative terminal is connected to the negative terminal of battery. Next, so the next topic what we are having is Ohm's law and resistance. So first, before going to that law, we just see some basic introduction about Ohm's law. So this Ohm's law is given by the person George Simon Ohm. Ohm's law is given by the person George Simon Ohm. And what he derived means, he derived the relationship between the 2 quantities. What are 2 quantities he derived? One it is the electric potential and another one it is the current. So what he did over here, he did an experiment. Let's see the experiment which was did by George Simon Ohm. He took a cell and is connected along with the key and a conductor, and an ammeter in order to measure how much amount of current is passing through the circuit, and an voltmeter in order to measure the potential difference which is created across the ends of conductor. Clear? So initially, based upon the given connection or given condition, he is noticing down the reading which is shown in the voltmeter as well as the reading which is shown in the ammeter. Voltmeter is used to measure the potential difference, whereas ammeter is used to measure the current. So in the first observation, he is noticing down that the potential difference which is created across the ends of conductor, for example, let's take it as 2 volt, and simultaneously is noticing down the reading in the ammeter, and then he is observing that 0.1 ampere of current is passing through the conductor. So this is a, for example, I just gave a value. This is the initial observation what he did. So now look at the circuit and we can able to see how many cells are there. Only one cell is there. Now what he did means he added one more cell, then the given combination will become as a battery. So by the time the second observation is noticing down that the potential difference which is created across the ends of conductor has got changed. So from what to what value it has been changed? From 2 to 4. That means once the battery has been added, the potential difference has got increased. Simultaneously, the amount of current which is passing through the conductor also has got increased. Now, he is adding the third battery. Again, he is observing the voltmeter reading. He is saying that the voltmeter reading got increased. Gradually, the ammeter reading also has got increased. So, based upon this observation, he is deriving the relationship between the two quantities. One is the potential difference and another one is the current, and he gave a relation. That means he gave a law, and that law only will be calling it as the Ohm's law. So in that law what he said means the amount of current which is passing through the conductor is directly proportional. So what is meant by directly proportional? So if you are seeing over here, the amount of current gradually it is getting increased when if the potential difference which is created across the ends of the conductor also is getting increased. That means we can say that potential difference is directly proportional to the current passing through the conductor. That means if more amount of current is passing through the conductor means the potential difference which is created in the ends of the conductor also is going to be high. If less amount of current is passing through the conductor means then you can say that the potential difference which is created across the ends of the conductor also is going to be less. So now based upon this the law was given by him, and the law states that the amount of current passing through the conductor is directly proportional to the potential difference created across the ends of conductor at a constant temperature. That means the temperature of the conductor must not remain the same. During that condition, potential difference and current will be directly proportional to each other. Now, on removing this proportionality symbol, we are going to introduce a constant term which is called as R. Here, the letter R stands for the resistance of the conducting material. So, what is the letter R stands for? The resistance of the conducting material, and this is a formula what we will be using in order to represent the mathematical expression for Ohm's law. So, what is the formula? V is equal to IR. V is equal to IR. So, here V stands for potential difference. V stands for potential difference, and then I stands for current. I stands for current and R stands for the resistance of the conducting material. This resistance of the conducting material will remain constant for a given conductor. The resistance of the conducting material will remain constant. Suppose if you are having any confusion in remembering this formula means we can remember the player name Virat. So in that the first three letters alone if you are taking over here means we can just write it as V is equal to I into R. Here V stands for electric potential, I stands for current and R stands for resistance, where R is called as the resistance of the conducting material. And how will be defining the resistance? It's a property of the conducting material. Each and every conducting material is going to have a certain property. What property it is going to have means it's going to oppose or regulate the flow of current. That means resistance is defined as the property of the conducting material which is going to oppose the flow of current. And what is the mathematical expression for resistance? R is equal to V by I. How we obtain this formula? V is equal to I into R. So if I need R alone means how the formula will rearrange? R is equal to, here I is in multiplication, while coming to the other side division. R is equal to V by I. This is a formula we will be using in order to calculate the resistance of the conducting material. If the given potential difference is constant means then I can write it as R is inversely proportional to the resistance. So what is the meaning of the word inversely proportional? If resistance of the conducting material is high, by that time the amount of current which is passing through the conductor will get decrease. By the time the amount of current passing through the conductor will get decrease. Or another condition, if resistance is low means by that time more amount of current will passes through the conducting material. More amount of current will passes through the conducting material. Based upon this condition we can say that resistance is inversely proportional to the current. Next, unit of resistance. A unit of resistance is ohm and it's named after the scientist George Simon Ohm, and the symbol what you are using over here, it's a Greek symbol, we need to pronounce it as omega, and here this symbol represents its ohm. So what is the unit of resistance? The unit of resistance is ohm, and the other unit of resistance is volt per ampere. What is the other unit of resistance? Volt per ampere. How we obtain this one? So from the formula, what is the formula? R is equal to V by I. V stands for electric potential. What is the unit of electric potential? Volt by, what is the unit of current? Ampere. So that will be equal to volt per ampere. While writing the symbols, we need to write it as V a power minus 1. So what is the unit of resistance? The unit of resistance is ohm or volt per ampere. How will define this 1 ohm? 1 ohm is defined as the potential difference which is created across the ends of conductor is going to be 1 volt. So let's take the conductor over here. So in this conductor, how much amount of potential difference is going to create means 1 volt of potential difference is going to create over here. That too, if 1 ampere of current is passing through the conducting material, 1 ampere of current is passing through the conducting material, that's what we'll be calling it as 1 volt. So I will define 1 volt. 1 volt is defined as a potential difference created across the ends of conductor as 1 volt, which allows the current of 1 ampere. So in symbols how we can write 1 ohm is equal to 1 V by 1 A. 1 ohm is equal to 1 V by 1 A. Next. So this resistance, it depends upon the following factors. Very important question. What are the factors on which the resistance depends upon? Means it depends upon the length of the conducting material and area of cross section and nature of the conducting material and temperature. On these four factors only the resistance of the conducting material will depends upon. What are the four factors again? Length of the conducting material, area of cross section, nature of material and temperature. Length is represented by the symbol L, area A, nature of the material is represented by the symbol rho, and here it stands for resistivity, and temperature is represented by the symbol T. Next, we will see some numericals which is related to the Ohm's law. So before that, what is the Ohm's law formula? V is equal to I into R. Now read the question. How much current will an electric bulb draw? That means the I value we are going to find if the resistance draw from a 220 volt source. Source means it's nothing but called as the battery. So this battery helps to maintain the potential difference. That means V value it is given. What is the value of V? It is in 220 volt. The resistance of the bulb is given as 1200 ohm. 1200 ohm. So what is the formula? V is equal to I into R. If I need I means the formula rearrange it as I is equal to V by R. I is equal to V by. Now substitute all the values over here. I is equal to, what is the value of V? 220 by, what is the value of R? 1200. Now, so remaining what is it? I is equal to 22 by 120. First check whether you can able to simplify the two numbers or not. So yes, we can able to simplify. If you are simplifying 22, we can just write it as 11, and 120 if you are simplifying means you can write it as 60. So now divide these two numbers. 11 divided by 60. Since it is a smaller number, add a 0 and keep a decimal. 160 is done. Eight 480, balance 20, again add a 0, 360 is done, 180. So no need to simplify. After decimal we got the 3 digits, so just stop up to there. So the current which is going to pass in that given circuit is going to be I is equal to 0.183 ampere. How much amount of current is drawn from the electric bulb over here? 0.183 ampere. Or you can just write this answer as I is equal to 0.18 ampere. Next, how much current will an electric heater coil draw from a 220 volt source? That means I is equal to, we are going to calculate, V value it is given. What is the value of V? It is in 220 volt, and the resistance of the coil is going to be 100 ohm. So what formula we can use? V is equal to I into R means I is equal to V by R. Now I is equal to, what is the value of V? V it is 220 by 100. If you are dividing these two numbers, we will be getting it as I is equal to 2.2 ampere. How much amount of current is passes through the electric heater over here? I is equal to 2.2 ampere. Next, the potential difference between the terminals of an electric heater is. So what is the potential difference maintained across the terminals of the electric heater? V is equal to 60 volt. When it draws a current of, so by that time how much current is taking over here? It's taking a current of 4 ampere. what current will the heater draw if the potential difference is increased to 120 volt. Since there are two conditions again, so for a convenient you can write it as V1 I1 V2 I2. So now we are going to calculate the I2. In order to find I2, first we need to know what is the resistance of the heater, because even if you are changing the potential difference also, the resistance will remain the same. First, by using these two data, let's try to calculate the resistance. So what is the formula? R is equal to V by I. R is equal to, what is the value of V? 60 by, what is the value of R? 4. So R is equal to 60 by 4 is going to be 15 ohm. 16 by 4 is going to be 15 ohm. Now we calculated the resistance. So even if the potential difference also is changing, the resistance is going to remain the same. What is the value of resistance over here? 15 ohm. Now we'll calculate I2. I2 is equal to V2 by R. So I2 is equal to, what is the value of V2? 120. It's given over here. The potential difference has got increased, but the resistance is going to remain the same. It's going to be 15. If you are simplifying these two numbers, it will be equal to 8 ampere. If you are simplifying these two numbers, it will be equal to 8 ampere. So now, if it is asked in a 1 mark means, directly how we can answer over here? By using the Ohm's law relation. What is the Ohm's law relation? V is directly proportional to I. That states that if potential difference is increased, current flow also will get increased. If potential difference is getting decreased, current flow also will get decreased. So initially, look at the value of potential difference. What is the value of potential difference? 60 volt. By the time how much current is passing? 4 ampere. Now, what is the value of potential difference in the second case? 120 volt. So by the time how much current only they are asking. So look at these two values. How much times the potential difference has got increased over here? 2 times. Then the current also will increase into 2 times. Then you can write it as 4 into 2, it is going to be 8 ampere. If it is in a form of 1 mark means, directly can answer like this. Apart from this means, we need to solve and then you can write the answer. Next, when a 12 volt battery, that means the potential difference of the battery is going to be 12 volt, is connected across an unknown resistor. That means the value of resistance we don't know. We are going to find a current of I is equal to 2.5 milliampere is given. How much ampere is given over here? 2.5 milliampere. So the first thing what we need to do means, we need to convert this milliampere into ampere. Yes. We need to convert that milliampere into ampere. In order to convert from milliampere to ampere, what we are going to do means, we are going to multiply the given number by using 10 to the power of minus 3 ampere. We multiply it by 10 to the power of minus 3 ampere. Now, what we are going to find? Basic formula, V is equal to I into R. If you need R means, the formula rearrange it as R is equal to V by I. R is equal to V by I. So now R is equal to, what is the value of V? 12 by, what is the value of I? 2.5 into 10 to the power of minus 3. Now take this minus 3 to the numerator. What will happen? It will change into plus 3. Then we can write it as R is equal to 12 into 10 to the power of 3. 10 to the power of 3 is nothing but called as 1000 by 2.5. So now R is equal to 12 into 1000 is going to be 12,000 by 2.5. So if you are simplifying these two numbers, so since there is a decimal place in order to reduce the decimal place, what you are going to do means, we are going to multiply and divide by using 10. With this multiplied and divided by using 10. So 12,000 into 10, it will become as 1,20,000, right? By 2.5 into 10, it's going to be 25. So first to simplify these two numbers, 5 5s are 25, 2 5s are 10, balance 2 will be then 4 triple zeros, and then 1 5s are 4 5s are 20, remainder 4, 8 5s are 40, double zeros. So the resistance of the conducting material is going to be R is equal to 4,800 ohm. What will be the resistance of the conducting material? 4,800 ohm. So this answer we can also express in kilo ohm. How we are going to write in kilo ohm? So R is equal to 4.8 kilo ohm. So what is the final answer? 4.8 kilo ohm. So how we wrote like that means, so what we are just going to do, we are going to multiply the given number by using 1000 and divide by using 1000. This 1000 is nothing but called as K. If you are dividing this 4800 by 1000 means, the final answer will be 0 0 0 0 cancel. For 48 by 10, it's going to be 4.8. As I said earlier, this 1000 you can also write it as kilo. What more? So R is equal to 4.8 kilo ohm. Next. So the next topic what we are having is factors on which the resistance of the conducting material depends upon. Already we saw what are the factors are there. So what are the factors? It depends upon the length of the conducting material, area of cross section, nature of the conducting material, and temperature. On these four factors only it depends upon. So now we will discuss briefly about how it is going to depend upon the length, the area, as well as the nature and temperature. So in this, what is the first factor we are having? Resistance depends upon the length of the conducting material. How it is going to depend upon means, resistance is directly proportional to the length of the conducting material. Resistance is directly proportional to the length of the conducting material. Directly proportional means, if length of the conducting material is high, that conductor will offer more resistance. Clear? That means if length increases, resistance also will get increased. If length decreases, resistance also will get decreased. Resistance also will get decreased. So let's take two conductors. One is X and another one is Y. Let's take the conductor, length of the conductor X as 10 centimeter, and the conductor Y, let's take it as 20 centimeter. Out of these two conductors, which conductor will offer more resistance? Either X or Y. Y only is going to have high resistance. So what is the reason over here? Because the length is high. If length is high means resistance also will be high, whereas the conductor X will offer less resistance. Reason, here the length is less, so the resistance will be less. Now on applying the Ohm's law, say through which conductor, either through the conductor X or through the conductor Y, the flow of current will be high. So we all know, as per the Ohm's law condition, resistance is inversely proportional to the current. That means if resistance is low, current flow will be high. So in these two conductors, in which conductor the resistance is low? In the conductor X only the current resistance is low. Then the current flow can happen easily in the conductor X. Let's take one more example. Let's take two wires are there, A and B. The length of the wire A is 10 meter and the length of the wire B is 5 meter. In these two conductor, which conductor offers more resistance, either A or B? Conductor A, the resistance will be high, whereas in conductor B, the resistance will be low. Now say about the current, through which conductor more amount of current will pass, either through the A or through the B? Through the conductor B. Why? Because here the resistance is low, so more amount of current will passes through the conductor B, whereas less amount of current will passes through the conductor A. Reason, here the resistance is high, resistance is inversely proportional to the current flow. Next, so the explanation is given over here. If the length of the conducting material is more, the conducting material will offer more resistance. If the length of the conducting material is less, the resistance will get decreased. Next, on what is the second factor it depends upon? It depends upon the area of cross section. What is the second factor? Is the area of cross section. And how it's going to depend upon means resistance is inversely proportional to the area of cross section. So let's take a conducting material. We all know the shape of the conducting material will be looking like a form of a cylindrical, and this part of the conductor only will be calling it as the length, whereas this segment is the right. This part of the wire only will be calling it as the area of cross section. This part only will be calling it as the area of cross section represented by the letter A. Now let's take two different wires are there. Both the wires are going to have same length. Both the wires are going to have same length but different area of cross section. Now let's name the wire as this is wire X and this is wire Y. So if you are observing here, the area of cross section is high, whereas here the area of cross section is low. As we said earlier, resistance is inversely proportional to the area of cross section. If area is high means resistance which is offered by the conductor will be less. So here area is high, then you can say that resistance will be low. Simultaneously, if area is low, resistance of the conducting material will be high. Here in the conductor Y, the area of cross section is low, then this conductor will have more resistance. Now through which wire the current can flow easily, either through the X wire or through the Y wire. In the X wire only the current can flow easily. Reason, here the resistance is low. If resistance is low means current flow will be high. Here the resistance is high, current flow will be low. So here how we will be getting the question means through which wire the current can flow easily, either through a thick wire or through a thin wire. Out of these two wires X and Y, which is considered as thick wire and which is considered as thin wire? X is considered as the thick wire, whereas Y is considered as the thin wire. If area of cross section is less means that type of wire will be calling it as thin, and area of cross section is high means that type of wire will be calling it as the thick. So the relation is there through which wire the current can flow easily over here, either through a thick or through a thin. The current can flow easily through a thick wire. Reason, area of cross section is high, resistance will be low, current flow can happen easily. Next, so here the relation is given. If area is high, resistance will be low. If area is low, resistance will be high. So the next factor, it depends upon the nature. And how it is going to depend upon means no two materials will have the same resistance. For example, let's take two different conducting material. One is copper and another one is aluminum. Whether these two conducting material will have the same resistance? No. The resistance of the conducting material will vary from one conducting material towards the another conducting material. Next, and how it depends upon the temperature. resistance is directly proportional to the temperature of the conducting material. That means if the temperature of the conducting material is increased means resistance also will get increased. If resistance is getting increased means the amount of current which is passing through the conducting material will get decreased over there. Simultaneously, if temperature of the conducting material is less, resistance will be less and current flow will be high. Why it's happening like this means whenever we are increasing the temperature, the mobility of the electrons will get increased. That means the speed of electrons will get increased. So due to the increase in the speed, what will happen means collision of electrons will takes place. Collision of electrons will takes place. Due to the collision, resistance will get increased. So what is the meaning of the word collision means one electron will go and hit over the other electron. So due to that, the resistance of the conducting metal get increased and temperature also will get, current flow will get decreased. Next, relationship between the resistance and resistivity. So we are going to introduce a new term which is called as resistivity. We'll just come to know what is meant by resistivity. Resistance means already we learned what is meant by resistance. It's the property of the conducting material which opposes the flow of current. Now, what is the relationship between resistance and resistivity? We all know resistance is directly proportional to the length of the conducting material. Let's take this equation number 1. Like then, resistance is inversely proportional to the area of cross section. Let's take this is equation number 2. So now what you are going to do, on comparing equation 1 and 2. So what we are going to do, we are going to compare this equation. Then how we can write this one? R is directly proportional to length and inversely proportional to area of cross section. Here I don't have any denominator, so I can just assume it as 1 is over here. Then how I can write this one? R is directly proportional to length, L into 1, L, 1 into A. So on removing this proportionality symbol, we are going to introduce a constant term which is called as rho, and here the rho stands for electrical resistivity. The letter or the symbol rho stands for electrical resistivity, or this one we can also call it as specific resistance. This one you can also call it as specific resistance. Now, what is meant by resistivity? It is a characteristics property of the conducting material. That means we all know resistance means it's going to oppose, but we need to know how much each conducting material is going to oppose the electric current. That's what we'll be calling it as the resistivity. And how we are going to define this one means resistivity is defined as the resistance of the conducting material per unit length in a unit area of cross section. Resistance of the conducting material per unit length in a unit area of cross section. So based upon the formula, how we can rearrange, or remember the definition means we all know R is equal to rho L by A. If you need rho means how the formula will rearrange? Rho is equal to R into A by L. Here the letter R stands for resistance. R stands for resistance. And the letter A stands for area of cross section. A stands for area of cross section and L stands for length. And how we can define based upon the formula? Resistivity is defined as resistance of the conducting material. This by is there, no? We can just use it as per. And the letter L stands for length. So we can define it as the resistance of the conducting material per unit length in a unit area of cross section. And then, since it is a measurable, we need to know what is the unit of resistivity. The unit of resistivity is ohm meter. How we obtain this equation? They will be asking us to write the derivation for the unit of resistivity. How we are going to derive the unit of resistivity? So first, what is the formula? Rho is equal to R into A by L. The unit of resistance is ohm. Unit of area is meter square and unit of length is meter. Now substitute all the values over here. Rho is equal to ohm into meter square by meter. So meter square is nothing but called as meter into meter. Then what I can do? I can cancel this m and the square over here. Then the remaining what will be there? Rho is equal to ohm meter. Now this is going to be the unit of the resistivity. So what is the unit of resistivity? The unit of resistivity is ohm meter. Next, on what factors this resistivity depends upon? Resistivity depends only upon the two factors. What are two factors are there? One is nature and another one is temperature of the conducting material. On these two factors only the resistivity will depends upon. What are two factors depends upon? One is nature and another one is temperature. And on what are the factors that does not depend upon? Means it does not depend upon the length as well as the area of cross section. Does not depend upon the length as well as the area of cross section. Let's take a condition. There are two wires are there. Both the wires are made up of same material. Let's take the nature of the material as copper. The first copper wire is having a length of 100 meter and its area of cross section is 1 millimeter square. Let's take the condition like this. And second copper wire is having a length of somewhat 5 meter and its area of cross section is 0.1 millimeter square. Now they will be asking us to say the nature or the magnitude of resistivity, whether which copper wire is going to have the high resistivity, either the first wire or second wire. The important condition is that both the wires are going to have the same resistivity. Both the wires are going to have the same resistivity. Here the answer is going to be same. Reason, both the wires are made up of same material. That means what material it is made up of? It's made up of the copper. As I said earlier, resistivity does not depend upon the length. Whatever the value of length and area of cross section it may be there, it does not depends upon. It depends only upon the nature as well as the temperature. Since both the wires are made up of copper, the resistivity of both the wires, that means the first wire and second wire, is going to be same. Next, so just remember this values alone. Based upon the range of the resistivity, we can divide the materials into three categories. One is the conductors, alloys and insulators. So whenever the range of resistivity is in a form of 10 to the power of -8 ohm meter, then we can say that the material is a conductor. -6 means it's an alloy, and if the values is in a form of plus means it's an insulator. So remember the range of the resistivity values over here. -8, minus means either it is going to be alloys or conductors. -8 means, that means if the resistivity is very less, it's going to be conductors, and then if the resistivity is less means it's going to be alloys, and if it is in a form of plus, that means it's in a form of +12 to +14, then the material will be calling it as the insulators. So now, why the heating element are made up of alloys rather than pure metal? So first, what is meant by alloys? Alloys is nothing but called as a mixture of more than one metal. That's what we'll be calling it as an alloy. Clear? Mixture of more than one metals, we'll be calling it as an alloys. And why these heating elements are made up of alloys means there are two reasons are there. One, the main reason it is alloys does not oxidize. Oxidize means burn. Clear? When it won't burn means whenever it is in a form of a high temperature. So what is the first reason? Alloys do not oxidize easily. And the second reason it is the resistivity of alloy is high. And compared to what? Compared to the conductors. Compared to the conductors, the resistivity of alloy will be high. These are the two reasons why the heating element in the sense, for example, if you are taking the geyser itself. So the conducting part of the geyser, it's made up of the heating element. That heating element will be made only based upon the alloys. We should not use the metals. Reason, the first reason it is heating element do not oxidize easily, and the second reason it is alloys will be having high resistivity. Next, a numerical question is an important 3-mark question. The resistance of the metal wire of length. That means the length of the wire is given. What is the length of the wire? It is given 1 meter. And the resistance of the wire is given as R is equal to, how much ohm it is given? 26 ohm at a temperature of 20 degrees Celsius. No need to bother about the temperature, just skip that value. If the diameter of the wire is D is equal to 0.3 millimeter, by that time what will be the resistivity of the material they are asking? So what is the formula? R is equal to rho L by A. If I need rho means how the formula rearrange? Rho is equal to R into A by L. So in the question we are having resistance L, but area of cross section is not there. First we need to find the area of cross section. In order to find the area of cross section, we are having a formula as in A is equal to pi R square. But even in the question, instead of radius they gave only the diameter. We all know diameter is equal to 2 times of radius, then R is equal to D by 2. But directly we can't substitute the value. Reason is given in the form of a smaller unit. So the first thing, we need to convert this smaller unit into a SI. In order to convert from millimeter to meter, what you are going to do means we are going to multiply the given number. Here what is the given number? 0.3. This number need to be multiplied by 10 to the power of minus 3. If I am multiplying like this means this millimeter can be converted into meter. Suppose I don't know the decimal means, then I can rearrange this value as 3 into 10 to the power of minus 4 meter. Now this is going to be the diameter. So now substitute in the formula over here. A is equal to pi value, let us write as it is pi R. What is the value of R? R is equal to D by 2 the whole square. So now A is equal to, substitute all the values. What is the value of pi? 3.14 into, what is the value of diameter we calculated? 3 into 10 to the power of minus 4 by 2 the whole square. So now A is equal to 3.14 into 3 the whole square 9 into 10 to the power of minus 4 the whole square 10 to the power of minus 8 pi. Here only most of the students will make a mistake. They will be just writing as it is 2, but we need to take this square. 2 the whole square, it will become as 4. Now simplify the numerator part alone. So the A is equal to multiply 3.14 into 9. If you are multiplying these two numbers, we'll be getting the area of cross section as 28.26 into 10 to the power of minus 8 by 4. Now divide these two numbers. 28.26 divided by 4, it's going to be A is equal to 7.065 into 10 to the power of minus 8 meter square. Now we calculated the area of cross section, so you can substitute in this formula and then you can calculate. So what is the formula? Rho is equal to R. What is the value of R? 26 into, what is the value of A? We calculated 7.065 into 10 to the power of minus 8 by, what is the value of L? It is given in the question 1. Now multiply the numerator part alone. 26 into 7.065, that will be equal to 183.69 into 10 to the power of minus 8 ohm meter. So this value we can also rewrite it as rho is equal to 1.8369 into 10 to the power of minus 6 ohm meter. So based upon the table, if you are seeing this one means what material it is going to be then? The given material, it will be manganese. So if you are looking at the table in the 11.2 in electricity chapter, based upon this value, the value of resistivity nearly it will be equal to 1.84 into 10 to the power of minus 6 ohm meter, and the given material, it is going to be in a form of a manganese. But we no need to memorize all the tables. Suppose if you are going to get any question based upon this, predict the material, means they will be giving a certain table, and from that given table we can identify the material. So no need to memorize the whole tables. Now next question, a wire of given material having length L, that means a wire is there, it's having a length of, what is the length of the wire? They didn't give any value, let's take it as L itself, and the area of cross section is A. If it is like this means the resistance of the wire is going to be 4 ohm. What would be the resistance of another wire? Since two wires are there, we can write it as L1, A1, R1. Now we'll write for second wire. L2 is equal to another wire of same material. Same material means, as I said earlier, the resistivity of both the wires is going to be the same. Since we don't know the magnitude, let's take it as rho itself. And then what is the length of the second wire is given? L2 is equal to L by 2, and the area of cross section of the second wire is going to be A2 is equal to 2A. If it is like this means, what is the resistance of the second wire only they are asking. Now first let us write the relation for the first wire. So what is the formula? R1 is equal to rho 1 L1 by A1. What is the value of rho 1? Rho L1 L and A1 is going to be A. If the given condition is like this means, by the time what is the resistance of the wire they said, it's going to be 4 ohm. Now let's write for the second wire. R2 is equal to rho 2 L2 by A2. What is the value of rho 2? Rho. Why I said it is going to be same means, because in the question clearly they said that both the wires are made up of same material. If both the wires are made up of same material means, the resistivity of both the wires is going to be same. Rho 2 into L2. What is the value of L2? L by 2, the whole divided by 2A. So this one you can write it as rho L by 2 whole divided by 2A. So if you are rearranging this one means, you can write it as R2 is equal to rho L by 2 into 1 by 2A. that will be equal to rho L into 1 rho L by 4A. So look at this value, rho L by A is nothing but called as 4. That means instead of rho L by A, we can substitute as 4 over there. So therefore R2 will be equal to 1 by 4 times of 4. So now what will happen? 4 and 4 will cancel each other. Remaining what will be there? R2 alone will be, R2 will be equal to 1 ohm. R2 will be equal to 1 ohm. So what will be the resistance of the second wire? The resistance of the second wire is going to be 1 ohm. Why are coils of electric toaster and electric iron are made of an alloy rather than pure metal? Reason already I said. What is the reason? The first reason it is alloys do not oxidize. Oxidize in the sense it's not going to burn easily at higher temperature. So this is the first reason. And the second reason it is the resistivity of alloy is going to be high. So these are the two reasons why the heating element, that means the coils of electric toaster and the electric iron, are made up of alloys rather than pure metals. Next, so the last question, why among the iron and which among the iron and mercury is a better conductor? So if you are looking in this table, the resistivity of mercury is given as 94 into 10 to the power of, I think, minus 6, I think so. The value is not visible clearly. 10 to the power of minus 6 ohm meter, and the resistivity of copper. Let me take the table. For mercury it is going to be 10 to the 94 into 10 to the power of minus 8 ohm meter, and for copper it's given as 1.62 into 10 to the power of minus 8 ohm meter. So look at these two values and say which one is going to have less resistivity, either the copper or mercury. Copper is going to have less resistivity. If resistivity is less, means resistance also is going to be less. Why is the condition as like this? Now let's take a relation. R is equal to rho L by A. A conducting material is there which is having a length of magnitude 1 meter and area of cross section, let's take it as 1 millimeter square or 1 meter square. Now what will happen? R is equal to rho into 1 by 1. So R is equal to rho. That states that if resistance is high, resistivity will be high. If resistance is low, resistivity also will be low. Here, as per the given condition, copper is having less resistivity. If resistivity is less, means resistance also will be less. The material which is having less resistance will act as a better conductor. That means which one is going to act like a better conductor over here? Iron. In the question they gave it as iron, right? So even that also, the resistivity of iron is going to be 10.0 into 10 to the power of minus 8 ohm meter. A1, this one also is having less resistivity compared to the mercury. If resistivity is less, resistance will be less, current flow will happen easily through which material? Through the iron. Next, which material is the best conductor in the given table? So in this given table, which is considered as the best conductor? So look at the table values, and if you are observing, the resistivity of silver is going to be very less compared to the given materials. That means which is going to act like a best conductor? The best conductor is going to be silver. But if you are not using this one, means reason it's more expensive compared to the remaining materials. So after this we'll stop the part 1. The next session will go along with the part 2. Thank you.